Welcome back again to this lecture. Last time we walked through some powerful Python features. Specifically during the last lecture, we discussed about comprehensions and file I/O. And today we are going to look through another couple of equally important features within the Python programming language. The first part of the lecture will be dedicated to passing functions as arguments, which you will see it adds an enormous amount of flexibility to your code and also reusability of the functions that you code up. And the second one is exception handling, which is a way for you to write more robust programs that can deal with runtime errors. Let me bring this up a bit so I can actually code. Now, before we delve into the details, a few reminders as usual. First one, project 1 is due tomorrow at 6 p.m. This is worth 15% of your mark. We are hoping that you're doing fine with this. Please trying to work through it as much as possible and trying to submit the assignment by the due time tomorrow. Grok worksheet is due on Monday. Grok worksheet 13, sorry, is due on Monday. And then project 2, which has been just, Han has given a nice overview of what's about, is planned for release on Monday, 16th, and that will be due on October 10th, so in 3.5 weeks. All right, so as usual, let's start with a couple of trivia about Python to warm us up. Well, you might have noticed that Python recognizes the type of your variables without you declaring it. And this is quite a specific feature to Python, which is called dynamic typing. So Python is a dynamically typed language, which makes it significantly different from other structural procedural programming languages such as C or C++, where you have to explicitly declare the type of a variable whenever you are creating it. This makes Python more flexible, but at the same time, it means that you need to be careful when you are reassigning variables, as you can run into value errors, which is one of the things that we are going to actually explore today, later in the second part of the lecture. Another fun fact about Python is that it is an interpreted language. So this means that Python executes your code line by line rather than compiling it at once beforehand, before execution. Programming languages, again, like C and C++, and in general many other programming languages, are instead compiled programming languages, which means that we have another program called the compiler that will take your code and compile it down to binary, and then that binary is executed at runtime. Instead, what happens with Python is that you have an interpreter, which is what we commonly see when I am running code from my terminal, and that interpreter takes your code, breaks it into tokens, and then from the tokens it reconstructs an execution tree. So it has all the dependencies of how it should run your code. And that tree is, which is called an abstract syntax tree, is then translated into bytecode. And there is then a virtual machine called the Python virtual machine, which is yet another program, which executes that bytecode. So there is no pre-compilation stage of your code itself. Obviously, this adds some overhead, so you need to be aware also the weaknesses of Python, but these overhead, yes?
Does that make it completely like slower than a compiled language?
Sorry?
Wouldn't it make it a lot slower than like something like C?
Correct. So this is one of the disadvantages. The observation is, wouldn't that make Python a lot slower than compiled languages? And the answer is yes. In many instances, Python will be slower than compiled language like C or C++, but there are ways around it. So you can pre-compile, for example, modules in a compiled language and then use them using Python. So Python is typically, when it is about high performance, operates more as a wrapper around compiled pieces of code. Okay, let's get into our first big topic today, which is functions as arguments. So you have seen already a number of useful functions that we've been using in Python, and here there is a list of some of them we've been using frequently: len, range, sorted, sum, max, maybe a little bit less, maybe you didn't come across enumerate, but they're all built-in functions, right? And obviously these functions are extremely useful, but what is even more useful is that these functions can be manipulated to provide an additional function as an argument that modulates what the actual behavior of your function is. And so I'm going to break this down into various pieces to let you understand more in detail what this means. So for example, let's say that I have the max function here, and let's grab this and start putting in our code. This should be sufficiently visible. Let's make it a bit bigger. Okay. So if I run my Python interpreter here and run this function, which is the max function, what is happening here is that max selects the maximum based on the fact that I have provided an iterable, which is a list of strings. Now, how does that list of strings how does it decide the maximum in this case? Unicode points. So basically what we are going to do here is a pairwise comparison of the strings within the list. And as I do the pairwise comparison, I look at the first character against the first character of the words and assign a higher score to the characters which have a higher Unicode point, which is just a number that encodes that particular character. Right? So now, I would like, for example, in other circumstances, to find the maximum based on another principle, right? For example, one way to find the maximum would be, let's say, could you return the string that has the longest word, so the string that has the maximum number of characters. Now, we can do this in a quite a simple way in Python by providing to the max function a second argument that is passed as a parameter called the key. And we do it in the following way. So let's grab again this code. So let's say key here is the parameter that decides which function we are going to use for the comparison among the elements in this list. And I can provide the len function as an argument here. And if I do that, the result is koala because it's the string that has the maximum number of characters. So now we are saying through that max function, give me the string at least the longest, and the comparison among the strings is going to be based on the length. Okay? Now that we have seen how to use length, let's take this a step further. Let me go back to the slide to visualize what we would like to do. So let's say that, for example, we have now a list of tuples, and each tuple has as the first element a string, which is a name, and the second is a value, which is a number, an integer associated with that particular string. Okay. Now, obviously, if we use max on this list, what is going to return is, again, the string, is going to return, sorry, the tuple whose first element is the string that, according to the Unicode points, has the highest Unicode points, okay, in a character-by-character comparison with the other strings. What I would really like instead is this function to return the tuple that is associated with the highest value, so which is the second element in the tuple, or I should call it a pair, because it's a tuple with only two elements in there. And to do that, I can define my own function and provide that function as an argument to the max function. So let's do that. Let's actually put this as a nice list. All right. And then we want to define our own function, which here in the slides I have called second, which probably better defined directly here. Let's call it, this is called second. And what this function is taking as a parameter is our tuple, tup. And then what do is to return directly the second element in the tuple. So tup1. Oops. There you go. Now I can take this function and provide it to max. So let's say max of my list. Then I have to provide the key, which is what decides which function I'm using for deciding what is the max, and second as an argument. So obviously we could have swapped the elements within the tuple, and that would have made it easier, but this is just to illustrate that you can provide your own built-in function. You can build your own functions and provide them to these other high-level functions. Okay, so one of the things which here is a bit annoying is that I am defining the function second only for the purpose of providing it as an argument to the max function. And then I'm not using that function anymore. On top of that, it's annoying because I have to use this def syntax, which takes a bit too many words. So in Python, or I should say Python provides a more concise way to define small functions without having to use the def statement. And that's using Lambda functions. What are Lambda functions? Lambda functions are essentially anonymous functions that you can define in one line. And so it's perfect in situations where you want to define a quick function for a one-time use, local use, which is exactly what we are doing here. So let's explain a bit how a lambda function works. We'll use this particular example here, which provides the same functionality of the function that we have defined earlier, called second. Let's clear this a bit. Okay, so here what we are doing is to use this lambda keyword to define a lambda function. And after the lambda keyword, we are going to provide, so this defines a function, okay? It's a local function. It doesn't have a name. It's anonymous. If you want, the name could be thought of being lambda. And then we provide a list of parameters as arguments to this function. In this case, we have only one argument, which is our tuple tup. But if you had more than one, you could provide them as a comma-separated list. Okay? Then we have a column here, and after the column, what we are going to put is the expression which is going to be returned by that function. So what that means is that lambda functions do not have return statements. They return directly the expression that I am coding up after the column. And so in this case, it's a very simple expression. It's just returning the first element of that particular tuple. And this is then applied by the max function in a pairwise way to the elements, and the job is done. So you will see lambda functions being used quite frequently in Python because we have this functionality of being able to provide functions as arguments. And typically you have these local functions which are defined only, need to be defined only once in that particular local scope. So let's do another example. For example, here, of course, this is not limited to max. One other thing that we can do is to use it, for example, on sorted. If we wanted to sort this list here of tuples based on the second element in the tuple, we just change sorted. We just change max with the sorted function. This is going to return an array. A list. I can call it my list. Now, one thing that I have discussed in the past about sorted that we have used is that in the past we have looked at how to return a list, or in general an iterable, which is sorted either in ascending or descending order. Obviously, what ascending and descending means, it depends on the type which is within the list, right? So do you remember how do we do that in sorted? Yes? Correct. So there is another parameter that we can use in sorted, which is what we call reverse, and we can set it to true or to false. The default is false, and we are going to get an ascending order, so from the smallest to the largest element, according to the metric that depends on the type. And if I set reverse to true, instead I'm going to go in descending order. So that is nothing else than another argument that I can provide here. So I can still do that by saying reverse true. and then I can print my list. So sorted is a little bit more special because you can give it up to 3, you can pass up to 3 arguments to this function. And so your reverse parameter is still going to work, and you can use it on top of the key to provide, that is used instead for providing a function as an argument. All right. Back to our slides. Oh, I should say, sorry. This is also another interesting, slightly more interesting example of using functions as arguments. So far, we have been using lists as our iterable. You can obviously use also dictionaries. And so if we have the following example, let's say we have this dictionary. In the dictionary, we have a number of subjects. The key is the subject name, and the value is the mark that a student has obtained for that particular subject. If we run mux on the results dictionary, it's going to return a string which is associated with the key, because the key is a string, and is going to return specifically the key that has, according to the Unicode points, the highest value. How can we use Lambda functions on these dictionaries instead? So let's go and do it. We define our dictionary, and then there is an important catch here. So as you can see, we are defining our Lambda function as before, but now our argument is subject. And the reason is that when we are iterating over the dictionary, we are actually iterating over, in this case, the keys. Not the key value pairs, the keys. So what this means is that if I want to extract from this dictionary the pair that has the maximum score, right, for a given subject, so the subject that has the maximum score, obviously I want the comparison to be based on the value and not on the key. But to do that, what I need to do is to grab back my dictionary, which is here results, right, and then provide the subject which had been provided as an argument to the Lambda function, so I can extract that value. And that returns as default, again, the key, but now is the key that corresponds to the subject where the student has gotten the maximum score. Is that clear? Any questions on that? Okay, good. Another couple of examples. Here there are even higher order functions that we can use. And these require you to be able to pass functions as an argument. So let's talk two very powerful ones, which are map and filter. Let's start with map. What map does is to take a function as the first argument. So this is different from the other ones because we are providing the function as the first argument. We don't have the key parameter in there. We just provide a function. And then we provide as a second parameter or argument for this function our iterable, such as, for example, a list. Okay, so let's see an example of this, of how to use map. So what does it do is to apply the function that I have defined as the first argument to all the elements in the iterable. And then is going to return somehow in a special format the new iterable which has been formed by applying that function to the original iterable. Let's see what I am talking about here. So let's say we have a list of numbers, and I can use my comprehension notation, for example, to define this quickly. 2, 6. Oh, what did I do? Oh, I forgot in range. Apologies for that. The error message wasn't that useful. It was saying something wrong. Anyways, so we have this list of numbers, and again, I can print this out. And what I want to do is to have a list which is a list of the squares of those numbers, and to that purpose, I can use the map function. So let's call these squares, and then I'm going to use the map function, okay? And I know that the second argument here should be numbers. How do I provide a function as the first argument? I use a lambda function. Okay, so lambda, then what's the argument of this lambda function? Well, it's going to take each one of the elements of my iterable. Let's call this element x. And what I want to return is the square of x, right? Which in Python, I can do this way. Okay. Now, there is an important catch. I really want a list at the end of this. Now, fortunately and unfortunately at the same time, map doesn't return directly an iterable, in this case a list. It returns an object called an iterator that we actually will study in a few lectures, in a couple of lectures, I believe. So if I assign squares to map, it's going to assign squares to an iterator. Instead, I want a list. Now, converting this iterator object to a list is as simple as writing list to wrap around the map function. Okay? And then I can print squares. Now, again, if you're thinking about iterators, we are going to explain them later on. I don't have the time to do that today, and in general requires a dedicated lecture. But one important thing about the reason why Python uses map this way is because it uses something called lazy evaluation. What that means is that the moment that I write map, the lambda function, and the second argument, that lambda function is not evaluated on all the elements of the list. In fact, that function is evaluated only in this case when I am in this case when I am converting that to a list. The reason why it does that is because map is a function that is used for data processing. You might have very long iterables, so lots of data, and you don't want that computation to be done at once. You typically want it to be done within a loop, and so one step at a time. So Python provides this functionality by using iterators, which is what we're going to study in a couple of lectures. Okay, another example is that of filter. So a filter function, let's go back for a moment to our slide. What instead does is, again, takes a function as the first argument, iterable as a second, but instead of applying simply the function to each item, it uses that function to decide whether to keep or discard elements within the iterable. Let's do a quick example. Let's say, for example, that from numbers here now, we would like to retain only the elements which are even numbers. Okay? So how do we do that? We use, obviously, filter. We can call the resulting list even numbers. And we have our filter function. Once again, this is going to return an iterator, so I need to convert it to a list. The second argument is numbers. And then the first argument is what I need to use to filter out the elements. So again, a lambda function, one element of that iterable at a time, and then I'm going just to check whether that is an even number. And this should not require explanation at this point, as we've done this many times. And then I can print that out. Okay? Any questions on this? All right, so now that we have learned how to use functions as arguments and lambda functions, let's apply this to a class exercise. What do we want to do here? We have a list of, obviously we want to use both functions as argument and lambda functions in this exercise. We have a list of dictionaries where each dictionary contains a student name, their grades in different subjects, and their status as a pass or fail. And we have 3 tasks. The first one is to filter out students who failed. The second is to sort the remaining students by the average grade in descending order. And the third is to convert the data to a list of tuples containing only the student's name and the average grade. Now, as usual, to make the task clearer, we should define immediately what is the data structure that we are operating on. Is this list of dictionaries, as usual, where each dictionary represents a student. The first element in the dictionary is the name. We've done this before. The second is grades, and the key is grades is a string. The value is another dictionary. And then the third is a status, where both the key and value are strings and indicate whether the student has passed or failed that course. So I'm going to grab this and run this in VS Code. And I need 2 people who are going to help me code up these 2 tasks. Who's going to help him? Let's do this coding together. No one feels confident enough? 1? Your friend is saying, you should be helping me. What's your name? What's the name? Can you raise a bit your voice? Dan? Okay, excellent. And I recollect your name is Maka, is that correct? Okay, excellent. So step number 1, just to define what we have to do, is to filter out students who failed from this dictionary that we have. So let's start from over there. How am I going to do this, Dan? So I have to use? Maybe probably we should grab one of these things. Let's see whether this works. There you go. Is it working? Yes. What do I do there? Okay, excellent. So we looked at filter. We need to use filter to filter out the state of these students. So let's call these past students. Right? And I want a list of the students who passed. So I have just explained how to use filter. Well, first thing, we need to convert this to a list because filter gives us an iterable. And we know that obviously the second argument of this is going to be students. Now, the question here is how am I going to define this function, which is obviously a lambda function, lambda, to filter out our students? Let's ask Tumaka. Let's make this work. There you go. Thank you. Okay, so what do I give as an argument here to my lambda function? So we give, remember, the lambda function is going to operate on one element at a time of our dictionary. Okay, so we give, let's call it student. Previously we called it X, we could call it X. There wouldn't be any difference, but this is more insightful. And then as you correctly stated, what we need to do is to check whether the status is passed or failed. That is the function that is allowing us to filter out the students. So each element here of students in the list is a dictionary, right? So this student thing is a dictionary, and what we have to check is the entry called status. And then what do we do with this? Exactly. So we simply check whether it is a pass, and that is going to provide a way to filter them out. And that should be it. Let's try printing this out to see whether we've done a good job. And that looks like it's working, as the students that I'm getting here, they have all passed. Maybe this is a bit too small. Let's see if I can make it bigger. There you go. Okay, so now we have our second task, which is sort the students, well, I want to provide a list which has the students sorted out by the average grade. So let's say just shortly sort students by average grade. Okay, so how do I implement this? Damn. What do we have to do here? So we have to provide still a list, right? So let's call it sorted students. What else have we looked at in this lecture? Yes? Okay, so one way to do this is to use the sorted function here. So we are not using map, we are not using filter. We go with sorted. And again, our second argument obviously is going to be the students who passed, because that's why we computed them in the first place, sorry. And then we, I was saying the wrong thing. I was using sorted as map. In sorted, the first argument is our iterable. The second, if I want to provide the function as argument, I have to use key as a parameter. And then the suggestion was to use a lambda function. Now, what are we going to do in this lambda function? Okay, so the function has to compute the average grade, which is what we want to return, so that sorted can use that average grade for making the comparison. So once again, student is our argument because it's the element in our list, right? And then I have to compute the average grade of this student. So how am I going to do this? Okay. So to do the average here, we have done it a few times. We have to add together all the grades. Remember, this is the data structure. Actually, let me make this bigger so it's easier to see. The second element in each one of the dictionaries, which in turn are the elements of the list, provides grade. So we need to run over those, sum them together, and divide them by the length, so by the number of subjects that I have, and that's going to give me my average. So typically, we do this in a concise way by using the sum function, okay? So I take students, in this case student, and then again it's a dictionary, I need their grades, and then I need here, what do I need here to be able to average this up? Yes?
We divide it by the length of the grades. So like we're calculating the average of the grades. We've already got the sum and we divide it by.
Right, so there are two things here. One is we do the sum, and then we, as you're suggesting, what's your name?
You can call me Emily.
Emily, excellent. So Emily, as Emily is suggesting, we need to divide by the length, which is a good suggestion. And to do that, we just can do student and grades, right? But here, this is not going to work, right? What do we need there? Dot values, right? So we need the values. We shouldn't forget that we need the values there, because we need to average over the values and not the keys. Okay, so this is pretty much job done, right? Except, and you can see that it's true that we are allegedly making it more concise and all in place, but I still need multiple lines when using functions as argument. So the last thing that we need is what we saw before, right? So we want them to be sorted in descending order, which we do with reverse to true. I might have made a mistake, but we'll see. Okay, excellent. Let's test this and see what happens. No, we actually did it well. So as you can see, they're all sorted with. We really don't know here because we're printing out, but we are not printing out the averages. But we can look at the marks and see that that should be correct. In fact, the third stage of the exercise is to make that more obvious by converting these to a list of tuples with names and averages. Okay, so let's write this down. Convert to a list, to a list of tuples with names and averages. Okay, so who wants to help me on this? Student averages, I'll just give it the name, student averages. Which one of you? Let's keep going. I like that everybody is, more people are engaging. Up there? You want to say something? You too? You had already the mic. Yeah?
We use list first.
Well, so what function do we need to use here? So we need to compute the average. This can be done in multiple ways, right? But there's obviously, we have looked only at one other function today. So what do we use?
We've learned map and filter, so I think we should use map.
Correct, right? Filter is not going to help us here. So we are going to use map for illustration purposes, to be honest. Again, there are multiple ways of doing this. And yes, I need to wrap it into a list because, again, it returns me an iterator. Now, as for map, we know that the second argument is now sorted students. And as usual, the main question becomes, what's the lambda? How do I do this? I really love what you said because that's exactly what I would do. Instead of rewriting and re-explaining the whole thing, we have calculated the averages up there in the previous step. So what we are going to do is just grab this piece of code, that's our lambda, right? And put it here. Right? And that should be pretty much it, I think, except that I'm having some errors somewhere. Map, key, student, this looks like it's fine. Oh, that's the issue. There you go. No. And that's when copying and pasting code doesn't really work. Oh yeah, the problem is actually here, right? I'm using this that I shouldn't really do. Okay, so that's why doing this together is nice, because you can tell me what is wrong as well. Okay, print. Let's see whether it works. That might work. Hopefully it does. Oh, yes. Obviously, because we have already sorted in descending order, this is going to maintain that order. And so, yes, that works. So we have a list here that, unfortunately, what is happening here is that, so one of the things that we haven't accounted for here is that we had requested to provide a list of tuples. So at the moment, we are returning just the averages, okay? So we need to wrap this up into a tuple, right? And we can provide student name here. And now we're done. Excellent. Any questions on this? No? In that case, I'll give you a few minutes of a break, and then we'll move to exception handling. We'll be back in, let's say, maximum 5 minutes, because we're running out of time. Okay, we should probably start coming back and get started again. As we don't have much time to go through the second part, we might do the exercise probably next lecture. We'll see. Okay, so second major topic today is exceptions. In Python, when something goes wrong during the execution of your program, an exception is raised. And when I say something goes wrong, I specifically mean a runtime error. And when an exception is raised, if you don't do anything about it, it will crash your program, right? So it will terminate execution. That's the correct terminology. So let's see the basics. What is an exception? So in general, in programming, this doesn't apply just to Python. An exception is an event that occurs during the execution of a program that disrupts its normal flow. So it's essentially when your code encounters an unexpected event or something unexpected in the execution, like dividing by 0, for example, or trying to open a file that doesn't exist. In that case, Python will raise an exception. Now, what exceptions are really telling us is something went wrong, but here is the catch. Not all exceptions need to terminate your program. You can use mechanisms, which in Python are called catch mechanisms or try except blocks, to handle these exceptions. And so what you can do by handling those exceptions is still decide whether to terminate the program, but more gracefully. For example, you can print out a nice error message, or you can actually continue the execution. So when do you think, for example, it's important that you do not terminate the program if you encounter an exception? Some examples. Yes?
Let's say a function certain inputs, but you input in the wrong format. So, let's say text int, but you input a string.
Right. So, for example, if you are taking, you would like to have an int, that's one of the examples that we have, and you're providing a string as an input, or vice versa, and that raises an exception, you might want to continue the execution. But let's say at a higher level, what are some programs that, imagine some programs that if an exception is raised, we terminate it, and that will be a bit of a disaster. Something very close to you, probably. Operating system, great example. You don't want to terminate your operating system because an exception is raised, unless it's a Even if it is a critical exception, it can typically recover from that. I don't want my computer just to go blank on me. Another one are web servers, right? Imagine you're playing a game online, and every time there is an exception, your server crashes. That isn't very pleasant. Okay, so there are many more cases where you would like to handle exceptions. Okay, so an important thing to remember is that when exception is raised, Python creates an object called an exception object, and this object is passed up to the call stack. What's the call stack? Is the chain of functions, or actually the tree of functions, that your program makes when it's executing the code. And so it goes up that tree, and it looks for some code to handle that particular exception. In Python, it's going to look for code which is in a matching except block, as we can see there. I will go through that in detail anyway. If it doesn't find that code, your program will be terminated. And this is what we typically see as a crash. So an example here that we have is this divide function. Let's grab it and do this example directly in here. You know, if I have a function of this kind, and then I return A divided by B, I might be in trouble depending on what A and B are. For example, if I do here print divide and A is a number, 1, and the second one is 0, and I'm trying to run this. Hope you can see this. Actually, let's clear it. I get a zero division error, and my program just crashed. Okay. And so we will see how to handle this soon. But before going into that, let's talk about exception modality. So this refers to how different programming languages handle errors and exceptions. You'll notice that not all languages handle errors in the same way. Specifically, Python uses automatic exception handling, which is very convenient. What this means is that Python raises errors and exceptions automatically whenever something goes wrong during execution. This is not true for other languages, such as C or C++, that instead require manual error checking. For instance, if you try to divide by 0 in C, the language doesn't raise an exception for you. So you should check that you're not dividing by 0 and then handle the situation where that is happening, if that is happening. Okay? But fortunately, we are in the Python realm, which makes things, for now, easier for us. Another important thing is, and I guess you might be wondering, how does even Python know when there is an exception, right? Who's telling Python whether there is an exception? Well, that's where the operating system is coming in. When a critical error, well, actually, when an error occurs, a specific error occurs, such as dividing by 0, the CPU knows it, it detects it. And this generates what we call an interrupt, which is a signal that to the operating system that something went wrong. And then the operating system is in charge to handle it. Now, the operating system responds to this interrupt by invoking what is called the appropriate error handler. Now, in our case, this is a Python runtime, the Python program, executable. So it calls back Python and says, something went wrong, you need to handle it, and passes control to the Python runtime, which takes over, at that point, the Python runtime knows that something went wrong and also specifically what went wrong and raises an exception, which is what we see. And then looks, as I said before, for a handler internally, so for code that can deal with that. If it doesn't find it, it terminates your program. And so here is a bit of a diagram, and this also shows you that when Python is looking for internally for the handler, is looking for a matching except block associated with that code that went wrong. Now, a quick note. I said that the operating system looks for an exception handler, and not all times the exception handler can be Python. There are errors that cannot be handled by Python in any way. And for example, a typical example is a violation of memory. So if your program is trying to access memory that it wasn't allowed to, the operating system says, no, this is a critical error, I will handle it, and the way typically the operating system will handle it is by terminating your program, okay? So typically hardware level exceptions like that are handled directly by the operating system, while software level exceptions such as the errors that we'll go through today, they can be handled, and they are handled in a way or another by the Python runtime. Now, obviously, by default, as I said, an exception makes your program crash if you don't do anything about it, but there is a way to catch these exceptions and handle them in more gracefully, so to say. And the way we do this is by using this try and except mechanism to catch the exceptions. So let's code this up. In the example that we had here, for example, we can do this directly here. All we have to do is to wrap our code that we would like to execute in a try block. And then after that, we can add an except block, right? Except. And this, in theory, should tell Python how do we handle the error. Now, in this case, we know what the error might be. And this error is a zero division error. Zero division error. So what we are telling Python is, if I run that code in the try block and there is a zero division error, you should do what's in the except block. And in this case, we could say just print something out. Warning, that was a zero division error. Right? And I can run this. And you can see that we are getting that error message there. Now, there are a couple of things that are important here. So in this particular structure. First of all, let's put a print statement here, which is easier. When we are having an exception, nothing will run after the point where the exception happened in the try block. For example, here, runtime will never make here. Right? So basically, once I have the exception, the runtime has to stop there and immediately goes to the except block and executes that particular block. The other thing is that I can actually resume execution after, because what I'm telling with the except block is that I have handled the exception. And so I can resume execution. I'm printing already in the function there, down here. So let's say my program is still alive. So I can keep going. And that's what we were saying before, your program doesn't need to crash necessarily. Obviously, if that error was critical, right, so I cannot really resume execution because there is no way to reestablish a state of the program that has a healthy execution afterwards, I should terminate the program. But if I can handle that, that provides you a way to do it. Okay. Now, another thing is that we can have multiple except blocks here. And each one of the except blocks can handle a specific error. So in the example that we have here, we are creating this list, nums, and we are trying to print out these, again, 9 divided by one of the elements in the list, and there might be different problems, and we would like to handle that in a different way. So let's run this code as well. Let's say, for example, here I have still in a try block, I am creating a list, nums. Oops. And then I'm going from 0 for I in range 0 to 3, for example. And I can then divide by nums 0, and that will give me a 0 division error, right? And so I have already one exception there, but I can put another exception, which is an index error, except index error, and that will happen if I'm trying to access, for example, an element which is out of range in my list. So I'm trying to access an element that it's not actually in the list. So let's write that down. Warning, out of range. Okay. Should really change this to just A. B is not used. Right, so if we run this, oops. What's happening here? Oh, just that was VS Code that was complaining for no reason. So we have our division by 0 error, program continues, but to get the other error here, I can put, for example, 4, which is not in there, and then run this program again. And you see that I've printed out the warning which is out of range because that is called an index error. Okay. Another thing that you can do, which is shown here, I won't go through this too much in detail, is, so there is a way, if I use the except block without providing the actual error string, it will run that code no matter what exception you encounter. Obviously, this is not good practice. And the reason is that you don't really know what is going on with the code, and you're trying to resume execution, and it's, even if you're terminating the program, it's not very informative. You're not telling the user or the other programmer or your friend or developer why something went wrong. So it is discouraged to use except that way. The best thing to do is trying to predict what might go wrong with your code and use appropriate except blocks that are more informative. One way to do that is, one thing that you can do when there are multiple errors is to gather them in tuples. So accept can accept as error argument a tuple with errors in there. And you might decide, that groups of errors can be handled the same way as in this case. For example, we might have thought in this particular case that the zero division error is a special case of the index error because I am choosing an index that selects a 0 in my array, and I shouldn't really do that, okay? In another error which is shown here is a value error, and that value error is what I was saying earlier. So Python is dynamically typed, and you got to be a little bit careful there. For example, in this case, we are trying to provide the index within our array from the user, from the keyboard, right? And the user can provide an integer, but the user, and all will go well, assuming that the integer is within range. If it is not within range, it will be caught by the first except, by the index error. But there is another error that is lurking there, which is if the user does something stupid and provides a string, for example. And in that case, I cannot convert a string which is, let's say, an alphabetical string, that cannot convert that into an index, and therefore I get an error there. And to handle that, that is called the value error. And to handle that error, we are using here this except block with the value error. Is this clear? Yes.
How does the value error differ from a type error if the value error is relating to the type?
So the value error in this case is saying that this particular value is this particular value should be an integer, which I guess it's very similar to the type error. I would have to look at specifically at what the definition of the two, I don't even remember, I need to look at whether in Python value error and type error are the same or not. So we went through this gathering things into tuples for handling multiple exceptions at the same time. There is another statement or keyword that you can use, which is finally, when you handle exceptions. And what finally does is to guarantee that that block of code is always executed. Okay? So this happens even if the except block contains a return in it. So we're trying to guarantee that either if the code returns safely, or if the code has an exception, we still want to run this, whatever is in the finally block. So let's look at a typical example. You have a file, okay, that you open. And as you know, whenever you open a file, you want to close it. You want to make sure that you close your file for various reasons. Here, in this case, in this particular code, we are trying to read from that file. So we open the file at the top of the function here. We trying to read and split the lines. This could have been done directly with one statement, which is read lines. And we are calculating the average length of a line, okay? So we sum the length of a line and then divide by the number of lines in there. And we calculate the average length that way, okay? So obviously, one error would be here, which is the first one. Your file is empty. There's no line, okay? So you will get a zero division error because the length will be 0 here. But another important thing is that even if you get that error, the file is empty, well, I still want to close that file because I want to return the resources to the operating system. It might have been more complicated. I might have been trying to write to that file. And I want to do that even if everything goes well, right? So in this case, what is going to happen is that no matter what, whether the try is successful and I am returning, or whether there is an exception and I am returning this string not defined, this finally block will be always executed and will guarantee that we are closing the file. Okay? And that's the behavior that we observe here. Okay, so you might wonder why just not avoiding errors entirely? Why do we need to catch exceptions? I guess it is obviously true that you should try to avoid putting bugs in your code, but first of all, it's not realistic. Errors will happen whenever they can happen, even to the best programmers. It's just the nature of this job, but the good thing is trying to handle those situations gracefully and safely in some cases. Obviously, there will be some pieces of code where bugs are not tolerated because it's a matter of security, for example. In those cases, you should write tests that account for various possibilities, as you have seen in the earlier lectures, to trying to avoid those situations. Okay, and we have also looked at some of the examples of codes where it might be very important to continue execution, but there are a couple of slides here that give you just an example of codes where it might be really difficult already to predict whether something is going to go wrong without putting an appropriate exception there. The code here is very verbose. I mean, just looking at that makes my head spin a little bit. And in those situations, you want to try to predict what are the inputs, what are the outputs, and how they are handled internally, and trying to add exceptions to handle potential bad situations. In general, as you can see here, errors can and will be associated with your users. So whenever you have a program where there is user input, it's not easy to control what the user is going to input to your program. We have seen one example of that with the value error exception, and those are cases where you would like definitely to have an except block there. And so this is one example exactly of that kind. In this case, we are trying to tell the user not to do something they're not supposed to do, so to input a correct value. So the user is supposed to enter a number here, which is then converted internally into a floating point number. And this is wrapped in a while true. Okay? So what this code is going to do is to loop until we get an error. So it's looping basically over this block, and once we try this, is going to loop until we get the correct value. Okay? So if we get a float, we are going to return and exit this loop. But if we are not returning, we are running our exception, we are printing this message. You gave the wrong value there. It's not a number. And therefore, we go back to our try block, which will in turn run our input function. And it will ask the user, will prompt the user again, asking for a number. Is this clear? Yes?
So except evaluates the Boolean false, is that it? Whenever it's triggered? Because while
If there is no exception, the except block is not executed. So an exception is not raised.
yeah, I get that, but the except block basically triggers that it's false. This is while true.
No, what actually is happening is when you return, you exit the while loop. So if the user gives the right input, we are returning and exiting that function. Okay? If the user gives the wrong input, the except block is executed, it prints out the error message, and then we go back to input, so it will keep asking for input. Perhaps it's a good idea to code this up quickly. I'll show what this does. Okay, and the number here. Oops. Oh, and that's VS Code that is definitely not helping me with the usual problem, but I can run this directly from here. Code should be here. You see? So it's going back and asking, and if I provide the correct value that I'm supposed to provide, then execution is terminated because I'm exiting that function. Okay, so hopefully that makes it correct. That makes it clear, sorry. All right, I just, in the last couple of minutes, well, perhaps we will cover this next time. So I would really like to, okay, so here is the difference between value error, and I will come back to this later, that answers the question that was asked earlier. So the value error is performing an operation which is undefined for that particular value. When you use the type error, we are using an operation which is undefined for that particular type. And this means that typically you are using a function, which is typically a member function of that particular type, and you're using it on another type. Okay? But since we are slightly late already, I would like to close this lecture here, and then next time we'll take a bit of time to go through these error types and give you a code example that we can, again, code up together to put together what we have learned about exception handling and also a bit of functions as arguments and Lambda functions. Thank you, and I'll see you on Friday.